In this video, we look at this MIT Integration B question. This appeared in the 2020 qualifying round. So this integral, we are going to solve this integral using a u-sub. But before we get to that point of doing a u-sub, we have to rewrite the integral, right? So I am going to start off with an identity from the double angle identities. We know that the cosine of 2x can be written as cosine square of x minus sine square of x. This is from the double angle identity, right? If you multiply these guys out, these are difference of two squares, so those ones are going to evaluate to the cosine of 2x. So this one, if you multiply these guys out, that is going to be equal to the cosine of 2x. So our integral I is the integral of sine raised to the power 4 of x cosine raised to the power 4 of x multiplied by, these are difference of two squares, and that multiplying them will give you cosine square of x minus sine square of x dx. And this is equals to the integral of sine raised to the power 4 of x cosine raised to the power 4 of x, and then multiplied by the cosine of 2x dx, because this one is the same as the cosine of 2x from the double angle identity. So here our integral, I'm now going to multiply this integral by 16 and divide the integral by 16. So I'm going to divide the integral by 16 and multiply 16 to the numerator, and 16 is 2 raised to the power 4. So this is sine raised to the power 4 of x cosine raised to the power 4 of x multiplied by cosine of 2x dx. So this one is going to be 1 over 16, the integral of 2 sine of x cosine of x, all this one raised to the power 4, and then we have cosine of 2x dx. And we also know from the double angle identity that sine of 2x is the same as 2 sine of x cosine of x. So I'm just going to replace this one with sine of 2x. So our integral I is going to be 1 over 16, then the integral of sine of 2x by raised to the power 4, and then cosine of 2x dx. And now let's do a u-sub. So we are going to let u to be equal to sine of 2x. So we differentiate du dx. This is going to be equal to 2 cosine of 2x. That is differentiating sine of 2x is cosine of 2x, and differentiating the angle and multiplying. So that implies that du over 2 is going to be equal to cosine of 2x dx. So in place of cosine of 2x dx, I'm going to replace that with du. And then I can take the integral from the x world into the u world. So I is going to be 1 over 16, the integral of u raised to the power 4, and then this one is 1 over 2 du. So 1 over 2 come out and multiply 1 over 16, that gives you 1 over 32, the integral of u to the power 4 du. And that is 1 over 32 u raised to the power 5 over 5, that is integrating, plus the constant of integration. So I is going to be equal to 1 over 32 times 5 is going to be 1 over 160, and then u raised to the power 5 plus the constant of integration. But what is u? U is sine of 2x, so that is going to be 1 over 160 sine of 2x raised to the power 5 plus the constant of integration. You can stop here, but let's do some simplification. So this is going to be 1 over 160, and then sine of 2x can be written as 2 sine of x cosine of x, all this one raised to the power 5 plus the constant of integration. So 1 over 160, 2 raised to the power 5 is 32, and then sine raised to the power 5 of x cosine raised to the power 5 of x plus the constant of integration. So I is going to be 32 over 160 is going to be 1 over 5. Then we have sine raised to the power 5 of x cosine raised to the power 5 of x plus the constant of integration. So that is the value of our integral. So if you integrate this, this is going to give you 1 over 5 sine raised to the power 5 of x. 1 over 5 sine raised to the power 5 of x cosine raised to the power 5 of x plus the constant of integration. So this one is the value of our integral. So if you find this helpful, please give me a thumbs up and subscribe to my channel. Comment down below and let me know how you can solve this question. Anyway, I thank you so much for watching this video, and I will see you in the next one. Bye bye.